Hello class, you are welcome to part 3 of our course. We are now looking at descriptive statistics. By way of overview, we will first of all consider the measures of central tendency. That is mean, median, and mode. And we'll also consider the measures of variation. And then we'll finally look at skewness and kurtosis. Let us begin with the central tendency measures. The data values of most numerical variables show a tendency to group around a specific value. And statisticians use a set of methods that are known as central tendency measures to help identify the general properties of that data. So the three commonly central tendency measures we want to consider are the mean, the median, and the mode. You may or may not have heard of these before, but I want you to be ready to learn. Let's start with the mean. We want to understand what the mean means. It's a balance point in a set of data values, okay? So a number equal to the sum of the data values for a variable divided by the number of data values that were summed. So for example, if I want to find the mean of the ages of students in your class, I would need to take the ages of each student in the class. So if you are 80 students, I will need to collect 80 ages, and then I'll sum all of these ages together, and I'll have a total figure. I'll write that one down. And as I mentioned earlier, there are 80 of you in the class. So the total I had for my summation, I'll divide it by this 80, and then the value I get becomes my mean. So the mean also uses all data values in a sample of population. So if you are doing a particular research and you consider a particular population and you select a sample out of it, to find the mean of that sample or the population, if you are working with the entire population, you will need to sum all, you cannot leave anyone out. You need to sum all the data values within that sample or population, and then you find their mean. So for example, we can have the average age of staff at a particular laboratory, or you can have the average waiting time until lab results are ready. The mean has a weakness. Individual extreme values can distort the balance points, okay? So a case where, for example, in your class, if majority of you span between age 20 and 30, I'll have a mean around the middle of 20, about 25 or 26. But if most of you are within age 20 and 30, and then there are about 3 or 4 students age 40 and 50, you realize that if I calculate the mean, I'll be getting a mean around 35, but that wouldn't be a true representation of the class, because I cannot say that, oh, the average age of students, I'll have to say that the average age of students is 35. Meanwhile, majority of you lie between 20 and 30. It's just a few, the 3 or 4 who are within age 40 and 50 who have distorted the balance point of your class age. We want to consider some examples now. It reads, although many people sometimes find themselves running late as they get ready to go to work, few measure the actual time it takes to get ready in the morning. Suppose you want to determine the typical time in minutes that elapses between your alarm clock's programmed wake-up time and the time you leave your home for work. You decide to measure actual times for 10 consecutive working days and record the following times. So we have 10 days, and we have the time between when you wake up and when you actually leave your home for work. How do we find the mean of these times? So first of all, we sum these 10 times and we divide it by the count of the times. There are 10 days we are considering. So we have 10 times we are considering. So we have the sum of the times, that is the sum of this particular row, and that gives us 396. And there are 10 of them, so divided by 10, and you have 39.6. So on the average, it takes 39.6 minutes for this particular person to get ready for work from the time he or she wakes up. So let's look at the notation. From the example we just saw, we realized that to find the mean, these x1, x2, x3, up to x10 are your data points. And then the 10 here was the count, all right? So we summed the data points and we divided it by the number of counts there are. X bar is a notation for mean. It's a mathematical notation that is representing a mean. So in general, we are using the letter N to represent the total count, and meaning the number of data counts. Then we use summation of xi to represent the sum of all the counts. Right? So sum of xi over n gives you your x bar. Now where n is the number of data values after, so the note under here is just what I have explained, all right? In the case of simple or raw data, as seen in the example before, you simply have your data values. This may be ages of people, some people at a birthday party. Sure, we have the younger ones and some parents, I believe, who are 20.39. So you simply sum up all of these data points individually, and there are 13 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So n is 13. You simply find the mean by summing these points to get 143, and you divide them by the total number of counts, which is 13. So the average age of people who are at the party is 11 years. Let's look at the case where we have our data represented in a frequency table, but the data is not grouped. So we call these ungrouped frequency data. So you may have a case where you have these ages listed here. It says the following are the ages in years of a class of students who registered for an examination. So these are ages of some students. We have 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 45 students involved here. We decide to represent this table in a frequency table, all right? So we have our X values, which represents the ages. The frequency represents how many of each student is 8 years, how many of each student is 10 years. So from here, we see there's only one student who is 8 years old, 5 students are 14 years old, 7 students are 16 years old, and so on. And the fx here, it's simply taking the x value here and multiplying it by the frequency. So when you sum our frequencies, we have 45. As said earlier, we are dealing with 45 students. So we expect the sum of our frequency to be 45. Then when we sum our f times x, we have 643. So to find the mean in the case of an ungrouped frequency table, your mean is simply the summation of your fx column divided by the summation of your f column, and that is equal to 643 over 45 in this case. So on the average, the ages of the students we have just considered is 14.3 years. If you sum up these raw data values, you're expected to have a total sum of 143. Yeah. But a frequency table simply helps you keep your data organized. Finally, under mean, let's look at the case of a grouped frequency data. We have an example here. The weights in kg of patients who reported at a school medical laboratory for a test is given in the table below. So we have the weights and then a number of patients. These patients who reported and were between the weights of 50 and 59 are 3. Between 60 and 69 are 8. Between 70 and 79, there were 21 such patients. There were also 2 patients who weighed 100 to 1, between 100 and 109 kg. So this is the data we have. As you can see, we do not have individual weights. The weights have been grouped, so we don't have the individual data points. So this is the case where we are dealing with a grouped frequency data. Now let's expand our table so we can include our frequencies. In the case of a group frequency data where you do not have access to the raw data, when you're trying to find the mean, you will need X data points to multiply by your f of X and so on. You will need to find X data points. In the case of a group frequency data, we use our class midpoint to represent our X, since we do not have access to the actual data point. If we had access to the actual data point, the actual data point would have been our X. So in this case, the midpoint of 50 and 59 is 54.5. The midpoint of 60 and 69 is 64.5, and so on for the remaining class intervals. We have the frequencies also provided here. And then at this point, once we have our X and our F, we simply multiply our F by our X, and we have that new column. This is enough for finding mean. F of X squared column has been provided, but we do not need it at this point of finding the mean. So let us ignore it for now. So you simply sum up your frequencies, and then you sum up your F of X column as data points as well. How then do you find the mean? Back to the formula. The mean is summation of fx over summation of f, which is equal to 4740 over 60. Finally, the average weight of patients who attended a laboratory is 79 kg. This brings us to the end of this session. Moving on, we will look at the median. Thank you for being a part.